All right, back from break, refreshed and ready to roll. Looks like this session will be the about the monitor, dispatching messages for IO to complete. And Joao, you go ahead and kick it off.
Okay, so this is basically what I believe we discussed much of this back on the last CDS. The thing is, we barely did any work. I don't think we actually did any work for about the whole having the monitors dispatching messages while independently and whatnot. And lately we've seen huge issues with monitors under heavy workload getting just stuck while performing operations on LevelDB, and those waiting times tend to basically have the monitors flapping all the way. So we really need some way to have the monitors continuing their work, especially replying to Lee's messages while waiting for operations to finish from LevelDB. I spoke with Sage last week, and the current idea is to just add a new Paxos state, such that once we get to that state, we relinquish control to another thread that will continue doing the housekeeping stuff while we wait for IO to complete. And that's basically it. I think that we should open this to discussion, although this is the most feasible option we have right now. So yeah.
Yeah, so just to give a tiny bit more background to the specific issue that we're seeing. When you have a big, especially big Ceph cluster with lots and lots of PGs, and that's under load, then you have a proportionally higher number or just more PG map updates that are flowing through the monitor, and so those update transactions can be just big. So I was seeing 50 megabyte like Paxos updates. That would take a second or two to commit, and then another couple seconds to like reread out of the LevelDB cache or whatever to update the in-memory state. The first obvious thing is just we can not block message processing while we're waiting for that IO to complete. And then I think additional steps would be to, deal with move to like reader writer locks or something like that, so that we can update that other information. But I think just starting with the IO part is probably the simplest, because right now, basically, we have a single thread that's processing all messages, and whenever it does anything, when it does any writes, it just sits there and blocks, and we don't do anything else until it returns. That obviously doesn't work well when the IOs are big.
The concerning part is that it doesn't happen just for 50 megabytes transactions. It can also happen for smaller transactions, as long as there's a compaction running on the background, because writes will block until the compaction finishes, and that can take, depending on the store and on the work on the write workload, it can take 1 minute, for instance. And during
is that a normal thing? Like normally any compaction will block all writes, or is that like if an unlucky write happens to be modifying something that's affected by the compaction?
I honestly don't know. Usually you'll have writes going through. I believe it's mostly when the write buffer gets clogged or something.
Okay. Yeah. Okay. Yeah, that makes more sense. This is level DB, by the way, that we're.
Whenever level DB compacts level 0, it will block. I'm honestly not sure whether it happens when other levels are being blocked as well.
Okay. So the first step is just to make the write asynchronous. I don't even think we need to worry about threads at this point. It's just a matter of making it so we submit the write, hand it off to the key value store or whatever, and then just wait for the callback. Continue processing messages. We just need to have a state so that we can continue doing work while we're in that, for that period while we're waiting for the callback for the write to complete. So in Paxos, we already have like an updating state. I wonder if this is a substate of updating?
I don't think we need to make to actually create a different state, because updating already represents basically all
what's going on.
The whole thing, yeah.
Yeah. So it's really, what is it? The store. What's it like? Get store. What's it? Apply transaction. Yeah. So basically, we need to look at all the apply transaction call sites. Well, maybe not the collect ones, like the ones that happen during the initial Paxos exchange, but the main one is the store state. Because the problem is that this code is written to be synchronous, basically, in all these cases. Right.
We can simply have a thread that will run Paxos transactions, and that thread can block at will instead of just working around the whole sync and async transactions. So we just have delegate that. Well, we push that to the queue because we already have that queue, and have this one thread grab the head of the queue, propose it. If it has to wait, it will wait, and the remaining threads will just progress as usual. And once that thread finishes with that proposal, it will grab the next head of the queue, and so forth.
Okay. So you're thinking just like a reader-writer lock, essentially, on the whole monitor, or on all the Paxos state?
We may not even need the read-write lock, really, because we just have to. Well, yeah, sure, we will have to have that read-write lock, but just protecting that queue, because all the services will have to push to have their state to that queue, to the tail. So we just have to protect access to the queue. Otherwise,
yeah, I guess all the
should be fine.
All the current stuff is all right. I guess it still means that while this background thread is waiting for the I/O, the places where it currently blocks, it assumes that no other activity is happening, and so we have to make sure that it's stopping at a safe point, right?
We actually will have to change the way we lock and unlock on dispatch, because there's a certain amount of messages, well, the Paxos messages, that will have to go to that thread instead of being handled by the monitor. So we will have to grab the MON lock, dispatch those messages to that thread, and unlock if that's one of those messages, because otherwise we can block the whole thing. I think. Yeah. Yeah. So if we grab that lock and we dispatch something to the thread and only unlock when dispatch finishes, we end up with pretty much um, the same behavior we have right now, which is single-threaded, regardless of that thread being run concurrently to the remaining workflow. So we really need to dispatch those messages and relinquish the lock so that a new message can be handled.
Okay. Yeah, I guess the thing that worries me. I want to make sure that what we do here is on the path towards sort of the larger changes that we're eventually going to want to make. Where, I mean, at the end of the day, we want to be able to satisfy any sort of reads for the Paxos state without blocking the writes. To be able to be prepared and sequenced, and obviously, but all the message processing shouldn't block on the underlying IO subsystem. Right? As long as everything is modeled such that there's a clear separation between things that are durable and things which are, still ephemeral and not yet persisted.
LevelDB, so we've had some trouble with this, but LevelDB does have pretty cheap read-only snapshots. You could actually just make a point of snapshotting every committed Paxos state and serving your reads from that. That's essentially what you want to do anyway, pushing it into LevelDB.
Yeah. Yes, but even then, most of it's usually in memory anyway, like the stuff that you're reading. Like it's mostly around the in-memory model and sort of the, right.
Yeah, once we update from Paxos, we basically read everything we need to, except for when we share maps with the OSDs, in which we actually go to LevelDB a lot to read a bunch of maps. I believe that's the only case where we actually go to LevelDB after update from Paxos. Well, there may be a couple more, but that's the one that is intensive.
Yeah, I mean, the thing that worries me basically is that if you look at, all writes go funnel through apply transaction, and if you grep for apply transaction in the tree, there are like 15 instances in monitor, which are mostly okay because they're mostly around all the initial sync stuff on startup, and we don't care if we block makefs and stuff. We don't care if we block there. There are like 8 of them in paxos.cc, and those ones I think do matter. Maybe some of them are less important because they happen during that initial Paxos exchange of collect and last and whatever, where it's just sort of resynchronizing after an election, and they'll always be small. But the big one is in Thor state, which is called, well, there's one in begin that I think is always small, so that one's okay. But commit and Thor state are when you have this like big pile of data that you're sending down, and that's in the handle commit handler. I guess that one, yeah, because it's updating a bunch of like in-memory state about like last committed and first committed, I guess, are the only 2 things. Okay, so that's not going to be so bad, I suppose.
So yeah, the one thing to be careful about is that even the smallest of writes can trigger a huge waiting time, because level EB may decide to compact, or may already be compacting, and we will wait on that compaction to finish. So even just updating a small version, or the last committed or something, or even a PN proposal number, just a couple of bytes may very well end up waiting a lot of time.
And this is what you observed when you wrote your little like
Yeah.
latency tester thing.
Yeah. Although it's most
concerning.
common to be triggered when there's a heavy write workload with bigger transactions, bigger than 1 megabyte, because you fill up the buffer quicker and the I/O is bigger overall. So it's not as common for lower values. So if we run that stress test with values up to a couple 100 kilobytes, it will not be as obvious. So yeah.
Yeah. But I guess if we started with store state, which is the actual transaction, then that'll get the lion's share of the latency. I guess I want to make sure that while that is actually happening, none of the other events can happen, right? And when that background thread does drop the lock, effectively, when it's doing that big update, it's the idea that any other Paxos message would just sort of get queued up. This is the queue that you were talking about before, and so they would all sort of they would serialize on that. But meanwhile, everything else could continue.
Yeah, the whole idea is that in this could be the cornerstone for a better message handling on the monitor, as long as we keep it such that right now we dispatch all Paxos related messages to one given thread that will handle those, and basically all disk blocks happen independently from the other messages, and as long as the other messages do not trigger any other message that eventually triggers a Paxos proposal has to go through the Paxos interface to queue a transaction.
There's already all that machinery is still there, already there. So that's so we don't have to do anything tricky there.
And that thread will have somehow to block itself.
Mm-hmm.
Well, actually, it doesn't. It will just wait for the Paxos proposal to finish, which already happens. We already have those queues in place, so we just put that message and be done with it.
So then, if you have some other event that is like calling a new election or a lease timeout or something that's going to sort of restart all this, will we just block for a minute until that background write completes before we continue? Just essentially flushing out that IO work queue.
I don't think we can abort a transaction or whatever in the middle if we want, so we will have to wait for that thread to unblock.
Yeah. Okay.
May it be
but those are the
30 seconds or 2 or 3 minutes, we'll have to wait for it. So
yeah.
I don't think there's much we can do in that regard.
If it's minutes, I think we're doing something really wrong. I would expect this to be. If it's seconds, it'll. I mean, these are the exceptional cases, right? When we're falling out of quorum, and in those cases, we would block for a couple seconds while we wait for the backend disk to catch up.
I'm pretty sure that we can get to at least a minute if we are dealing with hundreds of PG temps, because you have to.
I mean, if that's
because we're applying a bunch of PG temps plus the Paxos transaction, which also encapsulates the whole thing. So
Yeah. Well, I mean, if we're getting to that point, that means that the monitor is woefully underpowered, whether it's I/O or CPU or whatever, right? I mean, these updates need to take a second at most, or else we're just not we're not keeping up. Yeah.
yeah, those updates tend to take just a second or two at most if they are being written to the write buffer. But if at some point the write buffer is filled or the compaction is triggered,
Yeah.
then it actually depends on the size of the store.
Right.
But yeah.
Okay. Okay. Well, I mean, other questions? I guess. Do you feel like you have all the necessary pieces here to do this?
The what?
Do you have all the necessary sort of questions answered to move forward with this?
I think so. I'm pretty sure some other questions will arise when work is being laid down, but yeah, right now it seems feasible in the short term.
Yeah. Okay. Okay. So is the is the idea that you would have a work thread that you hand off the apply transaction call to, or would
Yeah.
you actually do the message processing in that, or would you hand the message off to it and put all of Paxos in the work thread?
Okay, so for ideally we would have a different thread dealing with all the messages that would not clash with or hinder or that could eventually hinder progress of other messages being handled. That would be the ideal case. For a first step, it seems that we can just create a thread that will handle the transactions and build from there, because that should be easier than doing the whole a new thread dispatching all the messages. And if
Yeah.
at least we will have a sense of whether that is worth pursuing or not.
So I wonder if like the really simple thing is just to create a work queue using our existing work queue class, where you hand it the pointer to the transaction for the key value transaction, and then like any place where it's safe to sort of do that work asynchronously, like store or whatever, we just hand it, just give it the work, and maybe with a completion thing at the end that does the refish stage after. And then any other place where it matters that there was an async write in progress, then we just call flush on the work queue. That makes sense? So for example, all of the other Paxos things that expect a valid, that might care that there's a write in flight, we just put flush at the top, work queue.flush,
Okay.
and it'll just block at that point and wait for it. That makes sense?
Yeah. I will have to look into how the work queues work.
Yeah.
I've never worked with them before. But, well, aside from looking at them while reading OSD code, but yeah. Sure, if we already have the means necessary, yeah, I think that would work.
Yep. Greg, are you on?
Right here.
Does that sound like it might be feasible, or
Yeah.
is it going to be more complicated than that? I think that the thing that worries me is that if you look at store state, it basically does the apply transaction, and then it does like 4 things afterwards. It rereads first committed after the transaction is applied. It calls sanity check, which I think doesn't really matter, and then removes legacy versions, which probably doesn't matter. But the problem is that the main store state caller is and handle commit, which just happens on the peons where you're just like handing it stuff. And so I think in that case it's pretty simple. You just have a completion that would do that refresh. But there are a bunch of other store states elsewhere that I think wouldn't take so kindly to being asynchronous, like in handle last, like during the initial Paxos exchange. I think those ones maybe we can't. Oh, those are the only two. Grep.
Yeah, it's just those.
Well, the master, I guess, at some point is also submitting it. But yeah, well, in any case, it's the thing that happens right after that it's going to be. We need to like retake the lock and finish cleaning up that state, and then
we may have to have a lock to protect the in-memory state when we finish applying the transaction, if we want to keep this sort of stuff in store state, because there may be a way to to split store state into the portion that is committed by the other transaction.
Right. Like compare transaction and apply transaction or something. Yeah. Yeah. That's probably the thing to do. Okay. And then the work queue item would block and do the write, and then retake the, for now, just like MON lock or whatever the global lock is. And then updated state, trigger the callbacks.
Yeah, it seems feasible on the short term.
Okay.
Once again, I'm sure questions will arise, but this is basically the whole yeah.
Okay.
Never mind.
Okay.
All right, we're coming to the end here. We getting here to wrap up. Give people a few minutes to ask questions here, in case there's any questions still floating around. Gregory, do you guys have slides or screencast or anything for the next one, or is it just a chat?
So we have a variety of stuff, but I think we're probably just going to kind of ramble on a bit about calamari.
Okay. All right. Well, it looks like there's no questions coming in, so let me switch the video over and we'll get started.